Alright, I am here, I am back after the summer, and I've got this other background now, and I'm here to talk to you about iodine. So I think iodine is a very cool element. It has the highest atomic number of all the stable, non-radioactive halogens, and it has the lowest electronegativity of all the stable halogens, and because of that, it is the least reactive of all the halogens. That doesn't mean it's not reactive. It's reactive enough that it kills germs well enough that for a while it was used as an antiseptic before modern-day antibiotics. It is also necessary for function of the thyroid gland, and the thyroid gland controls all sorts of hormone function, so it's necessary for life. And many people who lived away from the sea, where there was a lot of iodine in seafood and seaweed and all that kind of stuff, people would get iodine deficiencies. And if you get it bad enough, your neck, actually, the thyroid gland will swell up, and you get a condition called goiter, where your neck completely swells up. So nowadays, they sell iodized salt, which has a little tiny bit of potassium iodide in there, so you have enough iodine. Iodine is also used in the form of silver iodide to capture photos. Not anymore, since most people are using digital photos, but back when there was film. This is because silver iodide is not a very stable compound, and in the presence of light, it will decompose into silver and iodine, and therefore will leave a nice grayscale. So now I'm going to actually make some iodine out of some potassium iodide, and I don't have enough potassium iodide, and therefore iodine, to actually do any cool experiment with it right now. But I will be getting some more, and so keep your eyes out for another video in which I actually do some really cool experiments with iodine. Okay, here is some potassium iodide, and I'm adding just a little bit of water to it just so it dissolves. As you can see, it dissolves quite easily. Here I've got the solution, and now I'm adding a little bit of hydrochloric acid. What's going on is there's a double displacement reaction where I start with hydrochloric acid and potassium iodide, and I end up with hydroiodic acid and potassium chloride. So now that I have the hydroiodic acid, which is what I want, I'm going to add some bleach, which is sodium hypochlorite, or a very strong oxidizer, to it. It will oxidize the iodide in the hydroiodic acid to iodine. And the iodine is this dark reddish purple you're seeing there. Now, once the iodine concentration gets high enough, it'll actually precipitate out of solution, and it'll start floating up as chunks of solid iodine. There you go. You can see as I'm adding the bleach, or sodium hypochlorite, you see that it's floating out of solution and floating up as little chunks of iodine. Here's the end product. Now I need to purify it. Here I have a test tube full of some of the residue that I couldn't get out as solid, and what I'm doing is I'm heating it with an alcohol lamp so that the solid iodine will sublimate into a gas. There's no liquid phase at this at atmospheric pressure. And so the gas, the iodine vapor, will go up through the test tube and then hit this really cold Florence boiling flask that I have filled with water and dry ice. The iodine, upon hitting the Florence flask, will re-solidify and form solid iodine, which has been purified. Here is the end product. It's a little bit of iodine on the bottom of the flask. Here is me purifying the main part of the product. I added a little bit of liquid in there on purpose so that a little bit of water, so that the water vapor would help to bring the iodine vapor up, and the iodine could travel easily up to the Florence flask. And basically it's the same exact principle. Here is a slightly more dramatic shot with with a little bit more dry ice in the Florence flask. Here is my end product. I call it iodine paper.